Okay, welcome back to our EKG Mastery Series. In this video, we'll learn how to precisely determine the EKG axis with numbers. Okay, the secret for this video is to know how to draw the circle. This red circle, now we add the axes to it, and from there we can determine the accurate axis of the heart with numbers, with actual numbers. Okay, let's talk here. If we remember from the previous video, we have the heart and the axis is usually going to the left side. Okay, that being said, we are looking at the heart from different angles. All right, so I will draw this circle and you have to learn how to draw it with me. Okay, so just memorize how we do it. Okay, first of all, we have 3 pairs of leads, of the lamp leads. Okay, first is the lead 1, which is at 0 degree. This is the lead 1 here. Okay, and we have AVF, which is at 90 degree. Okay, so 0 degree, 90 degree. And this is here. If we want to write it here, the lead 1 will be like this, and AVF will be like this. Okay, so AVF is going at the 90 degree. Okay, just remember. Now, this is actually something unique to the heart. When we are drawing the axis, the positive angle is downward because this is the normal thing for the heart to be down. So the positive, like this is positive 30, positive 60, positive 70, and this is positive 90, positive 120, positive 150, positive 160, positive 80, 180. Okay, so the positive numbers are down and the negative numbers are up. Okay, so the first step, we have 2 leads, which are lead 1 and lead AVF. They are perpendicular to each other. This is the most important information. Now, next, we have AVL and lead 2. AVL and lead 2. Lead 2 is at positive 60, so it's between lead 1 and AVF. Perpendicular to lead 2 is AVL. AVL is at minus 30. These numbers is to be memorized. Okay, now the third pair is, we have lead 3 and AVR. They are also perpendicular on each other. The angle between them is 90 degree, okay? And lead 2 is 120, positive 120 because it's down there, and AVR is positive minus 150. All right, so again, we have 3 pairs, lead 1 and AVF. Lead 1 is 0 degree, AVF at 90 degree. After that, we have lead 2 and AVL. They are perpendicular to each other. Lead 2 at 60, AVL at minus 30. Now, the third pair is lead 3 and AVR. Lead 3 is at positive 120, AVR is at minus 150. Okay, this is very important. Now, what is the normal ranges? At what we need to know? This is the normal axis. The blue circle or pi is the normal axis, which is between positive 90 to negative 30. So anything in between these numbers is normal axis. Even minus 30 and positive 90 are normal. Okay. The orange pi is between minus 30 and minus 90. This is the left axis deviation. So anything is located here, this is left axis deviated. Okay, and the green pi is from positive 90 to positive 180. This is the right axis deviation. And this red pi here is the extreme axis deviation, the extreme axis deviation. This is the pi that we need to learn how to draw. It's very important. Always when you want to determine the precise axis, you have to remember this. And to remember this with practice, you'll start be able to just imagine it in your brain and solve the questions accordingly. All right, let's now go with step by step. First of all, determine the isoelectric lead. As we said in the previous video, the isoelectric lead, the positive deflection and negative deflection are almost equal. If you don't have an isoelectric lead, try to find the most isoelectric lead, okay? The most appropriate or the most isoelectric lead. After we determine the isoelectric lead, we look at the lead perpendicular to it. Okay, so if it is the isoelectric lead was 1, so the perpendicular to it is AVF, and so on. Okay, so we remember the 3 pairs. After that, the perpendicular lead, when we look at it, if it is positive, the axis will be the number of this arrow. But if it is negative, the axis will be opposite to this arrow. How we calculate this? This is easy. We take the number of this axis and complete it to 180. And we change the sign. If it's positive, we put negative. If it's negative, we change it to, if positive, we change it to negative. If negative, we change it to positive. Now, I know this is hard. Let's talk about the EKG practical, and let's see how to determine the axis. Okay, I will keep this pie here, the axis chart here to help us determine the axis. And with practice, you will just memorize it and just imagine it. Okay. So what is the first step here in this EKG? To determine the most isoelectric lead. If we look here, this is positive, positive, positive. This is negative. Oh, this is isoelectric. For me, this is most likely isoelectric. The positive deflection equals the negative deflection. So this is isoelectric. Okay. What is perpendicular to AVL? It is lead 2. So AVL always with lead 2. AVR always with lead 3. AVF always with lead 1. Okay, this is important. Okay, so we look at lead 2. Lead 2 here is positive, meaning that the axis is going with lead 2. So the axis here is positive 60, which is normal axis, right? The positive 60 will be here, which is in the blue pie. This is the normal thing. Okay, perfect. Let's take another EKG. Okay, let's look here. All right, now let's determine the isoelectric lead. For me, if we look here, this is negative, this is positive, this is positive, this is negative. The most isoelectric lead seems the AVR. If we look at the AVR here, it is the most isoelectric one. Okay, what is perpendicular to AVR is lead 3. Okay, lead 3 is positive, meaning that the axis is going with lead 3, and the lead 3 is at positive 120. Positive 120 is this, the right axis deviation, okay? Easy one, right? When you just practice it, it will be much easier. Okay, let's talk about this EKG here, all right? What we have here? All right, let's look at the isoelectric line. The isoelectric line for me, I believe this is lead 2. Look at lead 2. This is the most isoelectric line I can see. Okay, because the positive deflection is equal to the negative deflection. Okay, lead 2 is perpendicular to AVL. Where is AVL? Here is AVL, and it's negative. If it is negative, meaning that to calculate the axis, it should be opposite to this. What does that mean? It is here. Okay, so the angle here is 180. So how we do it? Very easy one. Just forget about the sign. Okay, now take the 30. Complete the 30 to 180. So to complete the 30 to 180, we need 150. And change the sign. It's negative here, so it's positive. So the axis here is 150, which is right axis deviation here. Okay, now if AVL was positive, we don't need to do that. It will be minus 30, and it will be normal. Okay, guys, I hope this is easy. I hope that is easy. Okay, one more example. Okay, look at this EKG. Okay. Sometimes students panic when they see this EKG, but that's easy to determine the axis. Look here. Lead 1 is most likely negative. Lead 2 is negative. 3 is negative. AVR positive. AVL, look, it's positive and negative. So this is the isoelectric line. This is isoelectric lead, AVL. Okay, what is perpendicular to AVL? It is lead 2. Okay, lead 2 here is negative, meaning it's not 160. It should be here, the continuation of lead 2. So what we do, we forget about the sign, and we complete the 60 to 180, which is 120, and we change the sign to negative. So the axis is negative 120, which is the extreme axis deviation. Okay. Let's see one more example here. Okay. Okay, let's talk about this. Okay, what we have here, if we look here, lead 1 is positive, lead 2 is negative, lead 3 is negative. AVR is isoelectric for me. Okay, AVM is positive, AVF is negative. So AVR is isoelectric. What is opposite to AVR is lead 3. We look at lead 3, it's negative, meaning the axis will be here. So how we calculate this? We get the 120 and continue it to 180, which is 60. And we change the sign from positive to negative. So the axis will be negative 60, which is here, and this is left axis deviation. Good. The last example here, let's talk about it. Okay, try to pause the video and try to find the axis by yourself. Okay. All right, let's continue. What do you think the isoelectric lead here? All right, for me, I think lead 1 is negative, 2 is negative, 3 is negative, AVR is negative. AVL is a little bit the smallest one, so I will consider this isoelectric lead. Again, guys, we don't need like a precise determination because the idea is if we don't have isoelectric lead, you want to find the most isoelectric lead. Okay, so for me, AVL is the most isoelectric lead. Okay, what is opposite to the AVF? Sorry, what is opposite to AVL? What is perpendicular to AVL is actually the lead 2, which is positive 60. Okay, when we look at lead 2, it's negative, meaning the axis is here. So what we do, we complete the 60 to 180, which is 120, right? To the 180, and we change the sign from positive to negative. So it's negative 120. And that's how we can determine the axis of the heart. That's it. Thank you for your listening, and I hope to see you in next video. Thank you.